Hey, what's up? Dan Fletcher here again with episode number 3 of our Let's Learn Ruby on Codecademy series. Okay, so in the last episode, we did a simple little Ruby program, just capturing basic user input. We learned how to do some modifications to that input and then show a string with the input from the user using string interpolation. So what's coming up next is control flow in Ruby. So we're going to learn how to write some more complex programs that can actually respond based on the user input. So let's get started with that. Click Start Lesson. Okay, so how it works. You may have noticed that the kinds of programs we've written so far in Ruby aren't very flexible. Sure, they can take user input, but they always produce the same results based on that input. They don't change their behavior in reaction to the environment, the collection of all the variables and their values that exist in the program at a given time. Control flow gives us the flexibility we're looking for. We can select different outcomes depending on information the user types, the result of a computation, or the value returned by another part of the program. Okay, so the instructions. Check out the code in the editor. There's some new syntax there, but we'll there's some new syntax there, but we'll bet you can guess what it does. Click Run to see the program in action. Go ahead and give Ruby an integer, that is a positive or negative number with no decimal bit. Before I run it, I'm just going to read through it. So it's going to print integer, please, space. We're going to create a user num, and we're going to set it to this new function that we saw, that we can see here, integer. And we're going to pass this gets chomp. So, I'm guessing we already were exposed to gets chomp in the last episode, or the last section. So we're going to get some user input. I'm guessing this is going to cast that input to an integer that we can presumably do some math on. So here we have an if statement. So if the value of user num is less than 0, we're going to say, or puts, you picked a negative integer. Else if the user number is greater than 0, we'll put that you picked a positive integer, and the default case we will put that you picked 0. Okay, so let's run it. Integer, please. I'll say -5. Enter. It says you picked a negative integer. Got a couple achievements for doing that. Wow. Okay, let's run it again. I'll just hit 0. It says that I picked 0. Run it again. I'll say 5. You picked a positive integer. Very cool. Let's go to the next. Pardon me. Control flow in Ruby. If. Ruby's if statement takes an expression, which is just a fancy word for something that has a value that evaluates to either true or false. If that expression is true, Ruby executes the block of code that follows the if statement. If it's not true, that is false, Ruby doesn't execute the block of code. It skips it and goes on to the next thing. Here's an example of an if statement in action. So if 1 is less than 2, and it is, print I'm getting printed because 1 is less than 2. Ruby doesn't care about white space, spaces, and blank lines. We sort of already discovered that in the last section when I was tinkering around. So the indentation of the print statement isn't necessary. However, it's a convention that Rubyists, Ruby enthusiasts, follow. So it's good to get in the habit now. The block of code following an if statement should be indented to spaces. So when you're done with your if statement, you have to tell Ruby by typing end. let me just copy and paste this in here and run it. So we get. So I'm wondering, is Ruby gonna? I think I read that wrong. Oh, right. The convention is indent 2 spaces. I wonder, do I need a new line here? How does, okay. So it does require a new line. I wonder if I can put this in parentheses. Will this work? Nope. Unexpected identifier expecting keyword then, or, oh, okay, so Ruby does actually have semicolons, it seems like, and that works. I wonder if I need the parentheses here then, if I have the semicolon. Interesting. I bet I can probably put that on the same line. Will it work without a semicolon? Oh, it does. I would have thought maybe I'd need to do that. Doesn't seem to matter. Ruby seems to be pretty flexible with how you can format your code. Kind of cool. So let's just put this back to the way it should be by convention, and we'll click next. Next. There we go. Else. The partner to the if statement is the else statement. An if-else statement says to Ruby, if this expression is true, run this block of code, otherwise run the code after the else statement. Here's an example. So if 1 is greater than 2, which it is not, I won't get printed because 1 is less than 2. Else print, that means I'll get printed. So instructions. Try it yourself in the editor. Use any expression you like in your if-else statement, but make sure both branches print a string. Make sure both branches print a string of your choice to the console. Okay. So yeah, we'll just flip this around to say greater than. I'll say else. Print. I don't know. We'll just say hello or hey. Cool. So it says hey. So yeah, this is always going to evaluate to either true or false. So I can say if false, right? So this will still execute hey. I can say if true for come on, true. I'm getting printed because, well, I'm getting printed because true is in fact true, right? Okay. I'm just thinking if there's anything so Ruby doesn't have these curly braces, I don't think. I wonder if they're optional. Let's just see. Unexpected curly brace. It's interesting that the code linter doesn't actually give me any errors. It's definitely not giving me nice indentation. If true. Let's see, can you do this? Let me get rid of this else. No. Okay. I'm guessing you just don't have curly braces in Ruby. It seems like, and I mean, at the beginning of this video I did say I've never attempted learning Ruby, but of course I've seen Ruby code, and it's definitely a very terse language, so it makes sense it doesn't have any curly braces. So let's just see that is still working. We'll click next. So else if. What if you want more than 2 options though? It's else if to the rescue. The else if statement can add any number of alternatives to an if-else statement like so. So if x is less than y, assuming that x and y are defined, put x is less than y. Else if x is greater than y, puts x is greater than y. Else x must be equal to y. Instructions: add an else if block to your if else statement in the editor. Honestly, I'm just gonna copy and paste in this situation, run it, and it passes. Yeah, not really anything to play around with. Oh no, what did I get here? Oh, I have to. It's funny, my code is failing. They don't care. I care. Let's fix it. So x, we'll just say 5, and y, we'll say 100. We'll run it. So x is less than y. If I were to say x is 500, we should get x is greater than y. We do. And if I make them both the same, I really wish I had Vim in here. That'd be so awesome. X equals y. Okay, now let's move on. Unless, ooh, cool. Unless is a directive in Blade, if you've ever used Blade templates before. Kind of weird the first time I used unless to think about, but when you get used to seeing it, can kind of avoid some unnecessary checks. Okay, sometimes you want to use control flow to check if something is false rather than if it's true. You could reverse your if else, but Ruby will do one better. It will let you use an unless statement. Let's say you don't want to eat unless you're hungry. That is, while you're not hungry, you write programs, but if you are hungry, you eat. You might write the program in Ruby like this: unless hungry, write some sweet programs. Else, have some noms. So we've started you off in the editor. Replace these underscores with the correct unless statement code, so your program prints out I'm writing Ruby programs. Okay, so unless hungry is true, right? So unless how do I say it? So if basically we're saying if, it's like this: if replace unless with if, right? If not hungry. So if hungry is false, I'm writing Ruby programs. And instead of doing this like if not hungry, we can actually just do unless hungry. That's the way that helps me anyways. Okay, so then else puts time to eat. And then end if, oh no, just end. That should work. Run. I'm writing Ruby programs. Okay, let's go next. Equal or not. In Ruby, we assign values to variables using the assignment operator, this equal sign, the assignment operator. But we've already used equal for assignment. How do we check to see if two things are equal? Well, we use this double equal, which is the comparator, also called relational operator. Double equal means is equal to. So we kind of went over that I think in the first episode of the series. If you can remember, I kind of pointed out like this equals, and this is true in like most programming languages that use equal for assignment. Other programming languages have like different syntax, like a colon, or like I can't remember what it was. There's one where it's like literally like an arrow like this. Anyway, this doesn't mean equal to, right? So if I change this to some number, I'm not saying I'm gonna reset this in a second. if I have some number and I say equal 8, we're just really, an arrow actually is probably the most appropriate symbol for this, because we're just saying, like, take this value, assign it into this. So if you're a math nerd, this is kind of confusing, because in a lot of programming languages, I can just reassign this anything I want. And so if you're thinking of this as equal to, this is impossible, right? This variable, like if you're kind of like on algebra terms, like this variable, say x, right? How can it be both equal to 8 and equal to 4? And it can't, because this isn't actually saying equal to. Anyway, I'm sure that probably makes sense. Let's just reset the exercise so I get my code back. And we'll move on. So the instructions is we've got two variables in the editor, is true and is false. Replace these underscores with equal, equal, or not equal to make is true evaluate to true and is false evaluate to false. So to make this true, I have to say not equal 3, right? And if I want to say that this expression is false, so 2 is equal to 3, that's false. If I run it, that should pass, and we can just to verify, right? Is true should print true in the console, and puts is false will evaluate to false, right? If I replace is false with 2 is equal to 3, we still get false here. If you do this, I'm not sure how Ruby handles it. Ruby just doesn't like it. But yeah, because this is an assignment operator, it's not saying 2 is equal to 3. Anyway, I'm sure that I'm probably giving that more explanation than it deserves. So back to passing code, and we'll click next. Less than or greater than. We can also check to see if one value is less than or equal to, greater than or equal to another. Those operators look like this. So we have our less than, we have our less than or equal to, we have our greater than, and we have our greater than or equal to. The instructions. We've set up a few variables in the editor. We want them all to evaluate to true. Your job, replace these underscores with less than equal, greater than equal to make the expression for each variable true. Okay, so 17 is greater than 16. Really wish I had Vim. 21 is less than 30. 9 is equal to 9. And 11 is, negative 11. Nice little catch there. Okay, negative 11 is less than 4. Should be good, right? Looks like it's not. Excuse me. Oh, right. Doesn't want me to use equal, equal. So yeah, here, so this is true, but this is also true. 9 is greater or equal to 9, so that should pass. I should also be able to do less than or equal, right? Both would return true. Yeah, and on that note, I actually can do greater than or equal to here. That'll still return true. All right, let's run it. I could also do less than or equal to, and this should still return true. And I can also, here I can do less than or equal, and that also is good. Good to go. Okay, so practice makes perfect. Great work so far. You know what they say. Practice makes perfect. Let's try a few more comparators to make sure you've got the hang of this. So for this round, we'll show you the comparators, and you set each variable to true or false depending on what value you expect the expression to return. Remember, no quotes around true and false. Okay, 77 not equal to 77. That would be false. -4 less than or equal to -4. That would be true. -44 less than -33. That's also true. 100 equal to 1,000. That ain't true. So let's run it and we're good. And comparators aren't the only operators. Comparators aren't the only operators available to you in Ruby. You can also use logical or Boolean operators. Ruby has 3, and, or, and not. Boolean operators result in Boolean values, true or false. The Boolean operator AND only results in true when both expressions on either side of the AND are true. Here's how AND works. So true and true is true. True and false is false. False and true is false. False and false is false. So for example, 1 is less than 2 and 2 is greater than 3. Less than 3 is true because it's true that 1 is less than 2 and that 2 is less than 3. Let's practice a bit with AND. Check out the Boolean expressions and set each variable to true or false depending on what value you expect the expression to return. So 77 is less than 78 and 77 less than 77. That is false. True. And 100 is greater than or equal to 100. Well, true is always going to evaluate to true, and 100 greater than or equal to 100 is true, so that is true. 2 to the power of 3 equal 8. Does it? 2 times 2 is 4, times 2 is 8, and 3 to the power of 2 is equal to 9. That is true as well. So we'll run that. We get a pass. Go to the next lesson. OR. Ruby also has the OR operator. Ruby's OR is called an inclusive. OR because it evaluates to true when one or the other or both expressions are true. So check it out. True or true is true. True or false is true. False or true is true. False or false is true. So this is like the complete inverse of AND, right? So AND only returns true if both sides are true. OR will only return false if both sides are false. There's probably an XOR operator in Ruby somehow. I'd imagine we might learn it in this series maybe. So set each variable to true or false depending on what value you expect the expression to return. So 2 to the power of 3 not equal 3 to the power 2 or true. So we have a true here, so it's going to return true no matter what. False or -10 is greater than -9. So we have false on both sides, so that should return false. I think, right? 10. -10 is less than -9. Yeah. And then false or false, that should return false as well. And we pass. So let's go to the next lesson. Not. Finally, Ruby has the Boolean operator not, which is this bang or exclamation, makes true values false and vice versa. So not true will evaluate to false, and not false will evaluate to true. Set each variable to true or false depending on what value you expect the expression to return. Okay, so not true is false. Not true and not true, so we get false and false. That will return false. Not. So 700 divided by 10 is equal to 70, which would evaluate to true, and then we're gonna reverse it with not. So this one also would be false. It should all be false. And we get a pass. All right, next. Combining Boolean operators. You can combine Boolean operators in your expressions. Combinations like this. So we're saying x and the evaluation of this, which is y or w. So if this returns true and this is true, then we have true, and then we have another and if z is true, then well, I don't know why they, oh, I see. Okay, yeah, so they're closing. So this turns true and this is true, then we get true, right? So combinations like this are not only legal expressions, but are extremely useful tools for your programs. These expressions, they're missing an S there, may take some getting used to, but you can always use parentheses to control the order of evaluation. Expressions in parentheses are always evaluated before anything outside parentheses. So, the instructions say, last one, set each variable to true or false depending on what value you expect the expression to return. Okay, so we have 3 is less than 4, which is true or false. So we have true on one side of this OR operator. So that expression is true. Okay, so and false or true. So this also would be true. And we know when you have true and true, you get true. So not true becomes false. And this expression, so we have false on this side, or 100 is not equal to 5 times 5, which is true. So we get false and true, which is false. And actually, sort of silly on my part to even worry about this. And can only return true if both sides are true. So if the first side is false, then this is false. And actually, they call that short circuit evaluation. Ruby probably, I'm assuming, is not even going to check this because the creators of Ruby are a lot smarter than I am, and they know that this didn't need to be evaluated to know that this comparator, or Boolean expression would evaluate to false. So actually, this is all I needed to read. Okay, and then so true or, and again, this is actually same situation. I don't even need to worry about what that evaluates to. True will always return true if one side is true, and so we have true there. That means that's going to evaluate to true, so let's run that. And we get a pass. Next. Nice work. Great work, in fact. So far you've learned how to use if, else, and else if, how to use comparators, and relational operators like equal, equal, not equal, less than equal, greater than, or greater than equal, and how to use Boolean or logical operators like and, or, and, not. Instructions: take a second to reflect on what you've learned so far. When you're ready, hit new to start the review exercises. So I'll leave you to reflect on what you've learned. I'm going to hit next. Looks like they're going to give us some more practice here. So if, else, and else if. All right, you're all on your lonesome. Well, not quite. We'll just leave this example here. Create an if-else statement in the editor. Make sure to include at least one else if. Each branch of the statement should print something to the console. It looks like they gave me everything I need to pass this, and they did. Well, let's just look at it. A equals 10, B equals 11. So if A is less than B, and it is, print A is less than B. If B is less than A, So actually, they kind of didn't go over this, but like I'm reading this like as a human, and I'm like, you know, reading these else statements, but actually the computer isn't, or sorry, not the computer, but Ruby isn't going to interpret or even bother interpreting these lines because this already returned true, so it executes this. This else if is ignored because the only reason this would ever get executed is if this was false. But anyway, let's make B less than A and run it, and we should see B is less than A, and we do. And then if we make them equal to each other and we run it, we should see B is equal to A, and we do. Very cool. Let's go to the next. Unless. Good. Now let's review the unless statement. So here's an example. A problem equals false. Print. Good to go. Unless. Problem. Interesting. Interesting. What does this do? Good to go. What? That's cool. All right. Remember, this is basically a shorthand if statement. It will do whatever you ask unless the condition is true. In our example, problem is false. So we don't have a problem. We print good to go. That is sweet. So yeah, when they first showed us unless, it was more like kind of like how I'm used to using it with Blade. It would be more like unless problem print good to go. Whoop. What happened there? Unexpected end of. Oh yeah, right. You need the end. Right, so that doesn't get executed because problem is true. But if there are no problems, unless problem, print good to go, so print's good to go. This is how like I'm kind of, the syntax is a little different, but the layout is the same when I'm using this in Blade. But I guess this unless will work for a statement that's on the left side, not just on the right. So that's cool. Good to go. Unless problem. Very cool. All right, let's go next lesson. Dare to compare. Now let's review comparators and relational operators. We've turned the tables a bit. Remember, comparators need to compare two values to each other. Well, excuse me. Remember, comparators need to compare two values to each other to result in true or false. So got some examples here. 10 is greater than 8, that's true. 8 is greater than 10, that's false. 8 is equal to 10, that's false. 8 not equal to 10 is true. We're letting you know what value, true or false, we want each variable to have, and your job is to add an expression that evaluates to the correct value using the comparators. So this should be false. So we'll do, okay, 5 equal to 6. That's false. Oh no. Is that? Yeah. That's cool. Should be false. 5 is greater than 6. And this last one, man. This last one should be true. So yeah, I don't know. 8. We'll just say 8 is greater than 4. Right. And looks like we're good to go. Next lesson. Billions of Booleans. Home stretch. Let's go over Boolean operators. So they show us a few examples. We've got 1 is equal to 1, which is true, and 2 is equal to 2, which is true. True and true evaluates to true. 1 is equal to 2, which is false, or 2 is equal to 2, which is true. False or true evaluates to true. Not false is true. And they're just showing another variant of syntax on reversing a Boolean. With and, both comparisons on the left and right must evaluate to true for the entire statement to return true. If the left side does not return true, it will not bother trying the right side. Said that earlier. It looks like they actually are covering it. With or, either the right or left side must evaluate to true. If the left side evaluates to true, again, like we went over earlier, the right side will not be tried because it has met the condition of one side being true. With not, you reverse the result. If you're false, you're now true. If you're true, you're now false. Just think of it as opposite day. Okay, the instructions. The code in the editor indicates what value, true or false, we want each value to have, and your job is to add an expression that evaluates the correct value using Boolean operators and or not. So this test should be true. Okay, I don't know. 5 equals 5 is true, and 3 is less than 3,000. That's true. So this should be true, and we'll use the OR operator. So again, we'll just do 5 is equal to 5, or 3 is greater than 3,000. That should still evaluate to true. This one should be false, so we'll do the exact same statement that I just did up there, only we'll do and 3 greater than 3,000 will be false. Let's run that. And it passes. And we got an achievement. Very cool. Up next. So coming up next is the 5th menth war. Using control flow, we can modify a user's input and return it to them. In this project, we'll make them sound like Daffy Duck. So that one took about 45 minutes to get through. If these lessons continue to be this long, I might have to break the different sections into like 2 videos, just so we don't end up with like hour-long videos. I don't know. Maybe you guys are cool with it. If so, then I'll just keep kind of doing it the same throughout. But yeah, so that marks the end of episode 3. I'll just keep tackling through the rest of this Ruby course. Thanks for watching. If you have any comments, any questions, leave them down in the comments below. Give me a thumbs up if you like the video. Click that subscribe button to get, my videos in your YouTube notification thing, whatever. Yeah, that's it. Thanks for watching. Cheers.